Task. Determine all natural numbers n greater or equal than 0 with the property that there are two permutations, a1 to an and b1, bn, of the numbers 1, 2, and so on up to n, such that the sum, a1 plus b1, a2 plus b2, and so on, are consecutive natural numbers. So we change kind of the numbers here, and we change them here, and we get like some consecutive numbers here in this sum. So what do we see? We let us name an plus bn as cn, and let us determine, it appears that we are about to have a clear formula for c1. So on one hand, what is cn? Sn. Sn is the sum of all numbers, a1 up to an, from the first to the nth, taken twice because it is numbers a and b. So the sum of up to n is n plus 1 over 2, and since we have it twice, we multiply by 2, and overall we get n times n plus 1. On the other hand, this Sn, it is the sum from c1 up to cn, and each next number is 1 greater than the previous one. So c2 is c1 plus 1, and so this is what we get. And so we get n times c1 plus 1 plus 2 and so on, plus up to n minus 1. And so this sum we add all together. So we get n c1 plus n times n minus 1 over 2. And this equals here n plus 1. Through obvious algebraic manipulations, we get c1 equals n plus 3 over 2. Aha! What does it mean? It means that c1 is odd. c1, that n must be odd number, sorry. N must be odd. Only for this it could work. Does it work or not? We will see. So now let us just try to have a feeling of how does it work. So if n equals 3, obviously, it could work. Then we get c1 by this formula. It is 3. The next one is 4 and 5. And so let's try to group A and B. If C is the largest number of 5, we get 3 under these 5, the largest of A. And then it compulsory gives us 2. And so then we have 4, and we must put the 3, which is left in B somewhere, only here. And so the rest just goes basically compulsory. And it appears we see some pattern, 3, 3, 2, and 2, 1, 1. And let us try to explore this pattern further. If n equals 5, we get C from 4, 5, 6, 7, 8. And then look, let's try to do the same. Under 8, the largest C, we try to put largest A and B. We put yellow largest A, then yellow largest B, then second largest yellow A, then second largest yellow B, then and so on and so forth. So here it ends up with 3. And the other numbers, they're compulsory numbers like C minus yellow number, the blue number. So what do we have? We have here the row 5, 5, 4, 4, 3. And then 3 is the same here, 3 and 3. 3 jumps from the yellow row to the blue row. And we continue, 2, 2, 1, 1. It's kind of like a chainsaw. Not in Texas, I hope. It's Austrian Olympiad, not Texas chainsaw. Right. Otherwise it would be a very cruel task. Okay, so let us now generalize what we have here. We have various C's, n plus 3 over 2, it's the smallest one, C1. The next one, C1 plus 1, is n plus 5 over 2, and so on. The last is n plus n plus 1 over 2. The previous one is this. And then again we start to putting A in a yellow chainsaw, n, some number skipped, n plus 3 over 2, n plus 1 over 2, and this n plus 1 over 2, the brown one, goes to B number, n plus 1 over 2, it becomes the number of a blue chainsaw that we pulled compulsory. So n The yellow numbers, they start from the greatest one and go basically up until half, n plus 1 over 2. And the blue ones, they start from here, because these brown numbers used twice, here and here, and go down up until in the very end, it starts to go 2, 2, and 1, 1. And this works. And this finishes the answer. So the answer is yes. It is all natural numbers are odd numbers. It works for the odd numbers. We found the numbers and we see for which numbers it could work, and we realize the algorithm of how to actually make it work. So we made it work. Therefore, the answer is all natural numbers. And this finishes everything.